Example 3.3, determine the voltages across the 3, 9, and 6 ohm resistors using mesh analysis. Step 1. Let's do the numbers. So if I look at my circuit, looks like this. We know that we have 3 loops. So if I look at these 3 loops here, I'm going to call this my loop 1, loop 2, and finally loop 3. So what I need to do here is that in order to calculate the 3 quantities that I want, I need to determine the number of loop equations we need. Since we have 3 loops, that means I'm going to have 3 loop equations, and I'm going to have 3 unknowns. And since I've already identified 1, 2, and 3, my unknowns are going to be I1, I2, I3. So everything has to be calculated from these 3 loops. So that means that I'm going to need from here, I'm going to need these currents to determine the voltage across the 3 ohm, the voltage across the 9 ohm, and the voltage across the 6 ohm. So I need these. So to make the calculations a little bit nicer, we need 3 additional equations to determine V3, V9, V6. I call these equations solver equations. So if I look at the numbers now, here's what the numbers say. I have 3 loop currents. So we already have to solve for the loop current. So I need I1, I2, I3 plus 3 solver equations for V3, V9, V6. So then what this tells me here is that I need 3 loop equations, right? I1, I2, I3, plus 3 solver equations for V3, V9, V6. So then my total number that I need here is 6 equations, 6 unknowns. And that will be I1, I2, I3, V3, V9, V6. Now you got to be careful here with the solver equation, because if you go Google it, you're going to have trouble. So the question is, what is a solver equation? And remember, when you see this word solver, this is Carlos's language. If you Google it, nobody's going to know what the heck I'm talking about. So here we go. In the language, right? So what is the solver equation? In the language of mesh, a solver equation determines the three voltages, right? The three voltage V3, V9, V6 in terms of loop currents. So here we go. Let's go determine the solver equations. So here, this is the solver for V3 ohm. So what do we have? We have a 3 ohm resistor. And the first thing that we have to do here is that we have to assume some polarity and draw in the loop current. And so when I look at this thing, here's my 3 ohm resistor. So we know this is the 3 ohm resistor. And I got to pick a direction for my polarity. So if I look at this guy, I'm going to say that this guy is going to be positive. That's going to be negative. This guy is going to be positive. That's negative. And in this case, I'm going to say this is positive and this is negative. Now note that these sign conventions are arbitrary. So they don't really mean that much. It's what you do with it afterwards that's important. So here's my 3 ohm. We already agreed that this has a polarity of positive and negative. Now I got to look at the loop currents. Now look at the red current. The red current, as it flows around, goes from positive to negative. So if I look at this thing, that means that this current is going in this direction, and that's going to be I1. Now, if I look across that resistor, there's the green current that's in the opposite direction. So then that means here is that this guy has to be I2. So because this is a passive convention, that means that V3 ohm has to be R3 ohm times I3 ohm. So this should be 3 times the quantity I1 minus I2. So if I now put this into matrix form, this is what I see. I see that this is going to be 3I1 minus 3I2. And then I'm going to bring the V3 over, and I'm going to set that equal to 0. That right there is a solver equation. Now I could do the exact same thing for the other 3 resistors, or 2 resistors. So I'm going to look at a solver for V9 ohm. So if I do that, I start the whole process all over again. And the way the process goes is it goes like this. It's the exact same thing. I assume a polarity. I have 2 currents. I've already given this polarity, that's my assumption. And then I have 2 currents. So in this case, I have current I1 flowing in this direction. Look at the circuit here. I have I1 going from positive to negative, and then I3 going from negative to positive. So there's that resistor, and then I have, excuse me, there's this current now, which is I3. So then here I go. So you can see that following Ohm's law, I'm going to write down exactly the same thing. I get V9 ohm. It's going to be R9 ohm, I9 ohm. So then I'm going to go ahead and put this into matrix form. Because of the polarity, I1 is positive, I3 is negative. So then this should be 6, nope, not 6. 9I1 minus 9I3 minus V9 equals to 0. There's my solver for the voltage of the 9 ohm. Now I do the same thing. In this case, it's going to be the voltage across the 6 ohm. So when I look at this guy, it looks something like this. I have a resistor that's going down. So this one is the 6 ohm, and we already defined the polarity. Again, it does not matter. So what I'm seeing here is that you could see that the green, if you follow the green, it's coming from positive to negative. The blue is going from negative to positive. So if I look at this thing, that means this guy's going down, I2. This one's going up, that's I3. So again, V6 ohm, it's going to be R6 ohm times I6 ohm. Now, if I put it into matrix form, what do I see? I see 6I2 minus 6I3 minus the voltage across the 6 ohm. So I'll just call V6, and that's equal to 0. So now I have all my solver equations. Now I'm going to put this all together. So if I put this all together, how about if we start from the beginning? Just to be clear on how we do this. So here we go. Let's start from the beginning. And get our equations. So the first thing I'm going to do, I'm going to go get the circuit, and it looks like this. Oops. Nope, apparently not. So let me try that one more time. So here's my circuit. So look what I'm going to do. First thing I'm going to do, I'm going to define my polarities. So if I pick I1 like this, I'm going to assume that my polarities are going like this, and like this. And then I have two other currents, 2 and 3. So we know we have loop equations here, right? We know we got 6 equations we got to have, right? We have 6 equations. We have 6 unknowns. So that means I have I1, I2, I3. And let's be careful. These are from the loop equations. And then I have V3, V9, V6. And then these guys are from the solver equations. So let's write them out. Okay, so here we go. So I have loop 1. And so I'm going to sum all of the resistors connected to loop 1. So this should be 2, 9, 3 times I1 minus the mutual. Note that there's two. There's a 3 and the 9. So this should be 392 minus 993. Are there any sources? Nope, that's 0. Now let's go to loop 2. So if I look at loop 2, I have 2 resistors, which will then be 3 plus 6, I2 minus the mutual with 1, minus the 6 with I3. Now let's look at the sources. So here we go. So if I come around the loop, you could see if I stay on the left side, KVL tells me that I get a positive, but if I take it to the other side, I then get negative 15. Let's look at loop 3. Loop 3 here tells me that I have 2 resistors in combination. So this is going to be 9 plus 6, 3 minus the mutuals. Note that there's the 9 with 1, and then there's the 6 with 2. Now let's look at the voltage sources. So if it's on the left side, I get a negative sign. But if I take it to the other side, I get a positive sign. So I get positive 21. Right? So now I have 3 solvers. Let's go to the solvers. This is the solver for what? V3. Now we just wrote these. So here's V3. So it's 3,1 minus 3,2 minus V3 equals to 0. So I'm just going to write that. So I'm going to get 3I1 minus 3I2 minus V3 equals to 0. Okay, let's go to the next one now. I have a solver for 9. So I need a solver for V9. Again, look at this. Equation 1, equation 2, equation 3, equation 4, and now we're writing equation 5. So if I look at this guy, what do I see? Well, according to what we wrote before, this is what? 9,1 minus 9,3 minus 9 equals to 0. So if I write this guy out, this will be 9,1 minus 9I3 minus V9 equals to 0. And then our last solver should then be, if I look at this guy, this is the solver between 2 and 3. So this should be 6I2, 6I3 minus V6 equals to 0. And that's my 6th equation here. So now all I got to do is I got to put this into matrix 1. Here we go. So here's how I'm going to write it. I'm going to call this I1, right? Here's I1. Here's I2. Here's I3. And I'm going to write my 3 voltages. V3, V9, V6. And then on the other side, I'm going to have my constants. So let's start lining them up. Here's I1 now. So I know this is my matrix here. Okay, look what I'm going to do here. So this is what I typically do. I1, I come in and I highlight all of the I1 terms. So now I'm going to write them in. So this is 2. This is 2 plus 9 plus 3. My next equation says it's minus 3. Next one is minus 9. This one is 3. The next one is 9. This one is 0. Okay, so here's my the start of my matrix. Now let's go to 2. So if I see a 2, I do an underscore just to make sure I get all my terms. Let's put them in. So the first one is minus 3. The second one is 3 plus 6. The next one is minus 6, minus 3, 0, and then 6. Let's go to I3. I3 here, right here, right there, right here, right there, right there. So let's go write those guys in. So this is -9. Second equation says it's -6. Next one is 9 plus 6. Then I go to 0, -9, and the next one is -6. Okay, let's go through the next ones now. So if you look at this next one, note that V3 only occurs in one spot, right there. So if I look at that, I have a 1 and a 2. So I'm going to get, here's 1, and I have 2. Everything else is 0, except for where V3 exists here. Oh, this should be V3, so this should be -1, 0, 0. Okay, now look at the next one. Now the next one we're going to look for is V9. So V9, there's only one location for V9, and it's right here. So it's going to be -1 right there. So if I go to I3, this is going to be 9. If I go to, excuse me, that's I1. I3 is -9, and then everything else should be 0. If I go to V6, you can see here, there's only one equation that has V6. So down here, I get -1, and then I have 2 and 3. So there's no 1 for 1, and then this is going to be +6, -6, 0, 0. There's my matrix. What about my constants? So my constants then, I look at the right side, it's going to be 0, -15, 21, 0, 0, 0. Okay, I think I'm writing too small, so I'm going to space them down a little bit better. And here's my constants right there. Okay. So now that I got it into matrix form, now I have a little bit of matrix magic. And matrix magic tells me I get I1 is equal to 3 amps. I2 is equal to 2 amps. I3 is equal to 4 amps. Then I get V3, which is equal to 3 volts. B9 turns out to be -9 volts. And then finally, B6, which is -12 volts. So these are the solutions from the matrix calculations. Right, those are my solutions. So I now know what the voltages are. So what are these? What does this mean? Right? So let's look at each of these individuals. Here we go. Let's look at the first one. The first one tells me I have a resistor that's 3 ohms. I know that this is the polarity right here. So what do I know? I look at I1. I1 is going like this, which is 3 amps. I2 is going in that direction, which is 2 amps. And then I'm going to put my 3 ohms right here. And then this will be V3. So according to this, you could see that V3 has to be, according to Ohm's law, it should be 3 times the difference in the current, which would be 3 minus 2, which then gives me a positive 3 volts. Check this out. This is exactly what V3 is equal to. So the calculator showed me right away. So what about this guy? So this guy is going to be V9 because it's the 9 ohm resistor. This is our polarity right here. So if I look at our circuit here, note that I have I1 going like this, which is 3 amps. And then I have the blue current going in that direction, which is 4 amps. So again, if I use Ohm's law says V9 is then going to be 9 times the current is 4. And you can clearly see that this guy is minus 9 volts. I1. So therefore, I get a V9 that looks like this. I should have been boxing these guys. And then finally, we have our last resistor, which looks like this. So in this case, we have a 6 ohm resistor, and we said that this was the polarity, which tells us that that's the voltage of this guy right here. So now what are the current directions? Well, I have the green current going down. That's I2 is equal to 2 amps. But then I have the blue current going up, but that one's bigger. So this is 4 amps. So if I look at this thing, this tells me then that the voltage across the 6 here is going to be 6 times the difference between these two, but because of the polarity, it should be 2 minus 4, which clearly tells me that this is minus 12 volts for V6. And that just tells me that the current direction is not correct, but opposite.